Hello, very good morning to all, and welcome to my class. From today, we are going to start our JEE Advanced Crash course. So, in this, we are going to cover all the important chapters that is very important for our advanced paper, right? And try to understand the topics on the basis of advanced level, so that you can all able to solve questions and do some different problems related to some topics, right? So we already decided our entire crash course that what we are going to teach you. So today is the first day of this advanced crash course, and today we are starting with the mole concept and equivalent concept. So this topic will take 2 days, today and tomorrow. So in 2 days we finish this mole concept and equivalent concept and try to solve numerical. So what is going to be the procedure for the class beta? This class is basically for 1.5 hours, right? So in 1 hour, or we say 40 minutes or 45 minutes, we are basically trying to understand the concept behind the topic. What are the concept? What concept you need to solve questions? And later on, last half of the class, that is 45 minutes, we are going to solve some PYQ that were coming in your advanced paper, right? So this is all schedule for this class. So let's start with the today class. I hope you all join the class and my voice and my screen is visible to you. Please tell me so that we can proceed our class for today, right? Okay. So I hope everything is fine. Okay. So let's start with the today class. That is, what do you understand by this mole concept and equivalent concept, right? So let's see. Yes. So basically, what do you mean by this term mole concept, right? So what is mean by this term beta mole concept? What is this mole basically is? So basically, 1 mole of substance is always means 6.023 into 10 raised to the power 23 entities, whether it will be atom, particle, molecules, ion, or anything. So 1 mole of the substance always means 6.023 10 raised to the power 23 entities of that substance, and it is called also Avogadro number, or we say Avogadro constant, and represented by Na. It means it is very much clear what is 1 mole. 1 mole means nothing, but it is equal to this much of entity, and what this much of entity is called Avogadro number, or we say Avogadro constant. For example, someone says 1 दर्जन means क्या? 1 दर्जन means 12 quantity. Half दर्जन means 6. So just like this, 1 mole is a quantity, means this much of particle or entities or atom or molecule is known as 1 mole. I hope this is clear to you. Good. Now, the amount which weight exactly same as this formula weight in gram, or atomic mass in gram, or molecular formula mass in gram is also known as 1 mole. For example, let's see, if I'm talking about oxygen, right? So we know all know that oxygen having 16 gram of molecular mass. So 16 gram of oxygen exactly equal to 6.023 10 raised to the power 23 entities or particle or atom of oxygen. It means the amount which weight exactly same as its formula weight in gram or this is known as, is also known as 1 mole. It means in 16 gram of oxygen we have 6.023 10 raised to the power 23 atoms or molecules of what? Atoms or molecules of oxygen. Similar, if I'm talking about carbon, carbon means 12 gram of carbon having this much of entity, 6.023 into 10 to power 23. So this is all about the mole concept. That what do you mean by this term mole concept, and how will you identify which one is 1 mole, and 1 mole is also equal to their molecular mass, or we say formula mass in gram. So I hope this is clear. Good. Now, the next point and the important point is the amount which has the same number of entities, that is atom, molecules, or other particle, as there are atom in exactly 12 gram of carbon 12 isotope. This number is equal to Avogadro number as well. That is 10 raised to the power 23, right? This is nothing but 10 raised to the power 23 and represented as Na. So this is all about the what is mole. What is mole called, and how many quantities are present in 1 mole. So this is how we can define the mole, right? I hope this is clear to you. Good. Now, there are some useful formula, as I know you already know this formula, but let's quickly revise this. The formula which is used to convert amount of substance into mole. How will you convert beta by using formula amount of substance into mole? The first formula is, and the most important formula is number of moles of a molecule. So what is number of moles of the molecule beta? Number of moles of the molecule is nothing but it is equal to weight in gram divided by molecular, or we say formula weight. For example, if someone give us 23 gram of sodium and they want calculate number of mole, how many mole are present in 23 gram of sodium, then we can use number of mole is nothing but weight in gram, that is 23, and we know that molecular mass of sodium is also 23, so it comes out to be 1 mole, right? So this is equal to 1 mole. So this is all about how will you calculate number of moles. For example, oxygen. Someone gave 16 gram of O2 and you have to calculate the number of moles. How will you calculate beta? Nothing but 16 upon mid total. Molecular mass of O2 is nothing but 32. So it comes out to be half mole, right? So this is how we can calculate, or how can you relate amount of substance and mole. So this is the relationship between amount of substance and mole. By knowing the molecular or formula weight, we can easily relate this equation, right? Good. So the second one is a number of moles of atom. So how will you calculate the number of moles of atom beta? So obvious, this is weight in a gram upon my atomic weight, right? So weight in gram divided by the atomic weight, so that we can calculate number of moles of the substance. The third one is how will you calculate the number of moles of particle? So we can calculate number of moles of particle by using the formula like number of particle divided by Avogadro number. If someone says ki let us assume number of particle, that is n, is given 6.023, right, into 10 raised to the power 20. And we know that Avogadro number is what beta? Avogadro number we already know, 6.023 10 raised to the power 23, right? Either it will be atom, molecules, or particle, anything, right? So it will be anything, atom, molecules, or particle. Right. Now, if someone says, just calculate number of moles of the particle, how many moles of particles are present in this, then we can calculate as, because we know number of particle is already given, that is 6.023 raised to the power 10 to power 20. Now, divided by the Avogadro number. What is this? This is 6.023 into 10 to power 23. This will easily cancel out each other, and this comes out to be 10 raised to the power minus 3. So 10 raised to the power minus 3 moles of particle are present. So this is how we can actually calculate moles when the different quantities are given. Either it will be for the molecules, for the atom, for the particle. So we can calculate by using such simple formula. I hope this is clear to you. Anyone having any kind of doubt, please ask me in the chat box so that I'll clarify your doubt. Any doubt related to this beta? No? Good. So this is all we can use for calculating number of moles and this, right? Now, the next one, this one is also very important. That is number of moles for the gases. If we want to calculate the number of moles for gases, then we can also calculate as volume of the gas at STP, which is in liter, divided by 22.4, right? If this is present in milliliter, then we can use, if the volume is in milliliter, right? If the volume is in milliliter, then we can use 22,400, right, in place of 22.4 liter. So always remember, when the volume is in milliliter, use this quantity 22.4, and when the volume is in liter, always use 22.4. So this formula is also used for the calculation of number of moles of the gaseous, right? Now, for example, let us assume. So these four are basically the formulas. How will you calculate these four? That is, this is the number one formula. This is the number two. This is number three, and this one is number four. So these four formula are basically used to calculate mass of solute, or we say number of moles, or we say molecular mass, because these three are interrelated to each other, right? Now, for example, 1 mole of NaCl is what? So we know that 1 mole of NaCl is equal to 6.023 into 10 raised to the power 23 units of NaCl. On the similar basis, if someone say, it means what? It means it will contain 6.023 10 to the power 23 units of Na plus, as well as 6.023 into 10 to the power 23 unit of Cl negative as well. Now, mass of 1 mole of NaCl is nothing but 58.5 gram. So we can say that now 58.5 gram of NaCl contain this unit, right? It means in 58.5 gram of NaCl, we have either three possibilities are there. Either 6.023 10 raised to the power 23 NaCl units. This will also possible, right? In 58.5 gram, because we know that now 1 mole is always equal to molecular mass, right? The number of particles that is present in the molecular mass is known as 1 mole. So this unit, or we can say this will contain 6.023 into 10 to the power 23 units of sodium only, Na plus, right? Or it will contain 6.023 10 raised to the power 23 units of Cl negative only, right? So this is how we can say, that is 58.5 gram of NaCl may be equal to this much of units of NaCl, or this much unit of Na plus, or this much unit of Cl negative. So I hope this is clear to you. Yes. Good. So this is all about how will you calculate this, right? Now, while solving problem related to mole concept, always keep in mind the following points. The first one, convert all in the same unit. Either it will mole, atom, mass, and then compare, right? So always either you convert all this into mole, or we convert all this thing into atom or mass. Then you have to compare all this quantity. And always remember one thing, mole is directly proportional to the molecules. So if the number of moles increase, then the number of molecules get also increases, right? So this is how simple formulas for calculating this thing. So these things are very important, and this thing is basically asked when some numericals are coming, you have to use the relation between this, right? So these relation are basically used. Now, let's see some other examples, how chemical equation and stoichiometry are related to each other, and how you can able to solve the question related to the stoichiometry, right? So the chemical equation and the stoichiometry, what do you mean by this term? Basically calculation based on the quantitative relationship. Just remember this thing, calculation based on the quantitative relationship between the reactants and products are referred as stoichiometry. So if someone asks what is stoichiometry, so you can say that calculation based on the quantitative relationship between the reactants and products are referred as stoichiometry. The goal of this calculation is to predict the relationship between the amount of the reactant and product of the chemical reaction. It means what are the use of such equations, beta? For example, if someone says N2 react with 3H2, right? N2 react with 3H2 to form 2NH3, and someone wants to calculate amount of NH3 formed in this reaction, then how will you calculate, beta? We can calculate, if we know the amount of reactant, then we can calculate amount of product as well. So the goal of this calculation is to predict the relationship between the amount of reactant and the product of the chemical reaction. How much reactant we take to get this much of product, how much reactant is required to get such much of desired product. So these are the interrelation or relationship between the reactant and the product, right? This is clear. Next, Always remember, never lose your goal while solving such problem, right? Use mole concept very carefully, and then also find type of sociometric problem before solving. So in the next slide, we are going to see different kind of sociometric problem related to different conditions. So we try to understand each condition so that we can easily calculate the numerical or questions based on the sociometry. So always use mole concepts very carefully, and also find type of sociometry problem before solving any questions, right? So let's see some different types of sociometric problems so that we can able to understand what type of question they generally going to ask, and what are the right procedure to solve such questions. I hope this is clear to you, right? Good. Now, the thing is, first of all, you must know about what is equivalent mass or equivalent weight. Then we are going to see some, different types of reactions. So what do you mean by this term equivalent mass or equivalent weight? How will you calculate this term equivalent mass or equivalent weight, beta? How will you calculate? Let's see. First of all, the number of parts of substance that combine with or displace directly or indirectly 1.008 parts by mass of hydrogen, or 35.5 mass of chlorine, or we can say 8 part by mass of oxygen, is called equivalent mass of that substance. Understand? So this is the basic definition of equivalent mass of the substance. What is equivalent mass and equivalent weight is called. So basically equivalent mass and equivalent weight is what, beta? This is nothing but the number of parts of substance that combine with or displace directly or indirectly 1.008 parts of either hydrogen, 35.5 parts of chlorine, or 8 parts of oxygen is called equivalent mass of that substance, right? So mathematically, how will we write this? So mathematically, we can write as equivalent weight of substance A divided by equivalent weight of substance B, right? Equivalent weight of substance A divided by equivalent weight of substance B is equal to weight of substance A divided by weight of substance B. It means, let us assume, if A is a metal and B is either hydrogen, oxygen, or chlorine, right? Then how will you calculate equivalent weight of metal, beta? Equivalent weight of metal is nothing but is equal to mass of that metal divided by mass of the hydrogen displaced into 1.008. Or in terms of oxygen, mass of metal divided by mass of oxygen combined into 8. Similar in case of chlorine, mass of metal divided by mass of chlorine multiplied by 35.5, right? So this is how we can calculate equivalent weight of a substance, or we say equivalent weight of a metal. So this is how we can calculate. Now this is the second formula, and this one is the third one. This second and third are going to be very important. The second one is equivalent weight of an acid. So how will you calculate, beta, equivalent weight of an acid? So it is nothing but the molecular weight of an acid divided by basicity. What is this basicity? Let's see with an example. If I'm talking about H2SO4, we all know that from chemical bonding itself, H2SO4 having a structure like this. This is OH. This is again OH. So this is H2SO4. Sorry. Now, in this, you can observe that there is a two replaceable OH ions, right? This is 2 OH. So its basicity is 2. So what is the basicity? So basicity of H2SO4 is nothing but is equal to 2. We all know that molar mass of H2SO4. What is molecular mass of H2SO4, beta? We know that 2 into 1 plus sulfur we have 32 plus oxygen we have 4 into 16. So it comes out to be, beta, 2 into 1 2 plus 32 plus 4 16 the 64. So it is equal to 98, right? So we know that molecular weight of the acid is nothing but 98. And what is the basicity? Basicity means number of replaceable H plus ion. So how many replaceable H plus ion are present here? 2 only, right? So number of replaceable H plus ion is only 2 here. So it is 98 divided by 2. So we can say that 49. So 49 is the equivalent weight of an acid. So this is how we can calculate equivalent weight of an acid. On the similar basis, if someone say calculate equivalent weight of S3PO4, right? S3PO4, S3PO5, we can calculate S3PO4. So how will you calculate beta? We know that this having P double bond O, this is OH, this is again OH, and this is again OH, right? So 2, 3, 4, 5, right? And this is P and 1, 2, 3, and 4. So 4 oxygen, 3 hydrogen. So what is the basicity? How many replaceable H plus are present here? 3, right? So there are 3. So we can just calculate the molecular mass, which is equal to 3 plus phosphorus. We know that phosphorus having molecular mass 31, and this is 4 into 64. So it comes out, sorry, 4 into 16. So it comes out to be 3 plus phosphorus having 31 plus 64. Just add them. So we know that 64, 31, so 4, 1, 5, 6, 3, 9, right? 9. So this is 95, 95 and 398, right? So this is also equal to 98. So just divide this 98. So 98 divided by 3 here, because in this number of replaceable ion is nothing but 3. So we can calculate the equivalent weight of an acid like this. I hope this is clear to you. Is it clear to you, everyone? How will you calculate equivalent weight of an acid? Anyone having any problem, please ask me. Yes, beta. Anyone having any kind of doubt, please ask me. No? Okay. So now we proceed to the next, right? So this is how we can calculate the equivalent weight of an acid. On the similar basis, if someone say how to calculate equivalent weight of a base. Okay, so how will you calculate beta equivalent weight of a base? So on the similar basis, just like a equivalent weight of an acid, we use molecular weight of the base and divided by the acidity. Acidity means what? Number of replaceable OH negative ion. Now, let's see with some example. Okay, so that you can able to understand. Now, if I have to calculate the equivalent weight of an NaOH. So we know that NaOH having molecular mass what? Na having molecular mass 23 and O 16 plus 1. This is equal to 40. So in NaOH we have number of replaceable OH ion is only 1. So 40 divided by 1, that is equal to 40. It means equivalent weight of NaOH or molecular mass of NaOH is equal to same. Right? Because here N factor is only 1. We are going to see and what is N factor as well. Right. So similar basis, if someone says how to calculate the equivalent weight of MgOH2, then how will calculate beta MgOH2? Tell me, how will you calculate equivalent weight of an MgOH2? Yeah. First of all, what is the molecular mass of MgOH2? Can you suggest me what is the molecular mass of MgOH2? We know Mg having molecular mass 24 and there's 2O. So 2O means 32 and 2 hydrogen as well. So it comes out to be what? That is 24 and this 2 and 2, 4. That is 28, 28 and 30. 28, 38, 48 and 58. So this is equal to 58 and divided by what beta? In this, how many replaceable OH are present? There are 2 replaceable OH are present. So 58 divided by 2. So it's equal to how much? 58 divided by 2. 29. Right. So this is the equivalent weight of an base. So I hope this is very much clear. How will you calculate equivalent weight of an acid and equivalent weight of a base? Right. Now, how will you calculate equivalent weight of a salt? So this is also play a very important role. So the First formula, that is equivalent weight of an salt is molecular weight. This is simple. This is very much similar to the equivalent weight of a base and acid, right? You have to calculate the molecular weight, and you can easily calculate because you know how to calculate the molecular weight of the salt. In questions, some data is already provided, like the molecular masses of individual sodium, carbon, oxygen. So you just by knowing and just by adding this thing, you are able to calculate the molecular weight of the salt, just like how I calculated, right? Now, this one is important. Divided by the total positive valency of the metal. For example, in Na2CO3, we all know that Na2CO3, we all know that carbonate ion, we having Na having plus, so 2 plus, and CO3 having minus 2. So total positive charge is 2, right? So total positive charge is 2. How many? Plus 2, right? Similar, if the question is come like copper sulfate, if the question is like copper sulfate, then how you can calculate beta? Copper sulfate having, what is the positive valency of the metal in copper sulfate? Can anyone tell? What is the positive valency of metal in copper sulfate? Yes, that is plus 2, plus 2. Similar in Zn4, Zn having plus 2. So this is how we can actually calculate equivalent weight of an salt as well, right? So this is the right way to calculate the equivalent weight of an acid, equivalent weight of a base, and equivalent weight of an salt. So this is how. Now, let's move to the next important thing. This is the fifth number, and this one is also very, very important. That is, how will you calculate equivalent weight of substance that undergo oxidation and reduction? And this one is very important because in advance, many questions were come from this topic as well. You have to calculate the oxidation reduction of equivalent weight of this term, right? So let's see how will you calculate. So we know that oxidation and reduction is equal to equivalent weight is equal to molecular weight. This is similar in every case, right? Molecular weight. Now, what is divided here? So molecular weight divided by change in the oxidation number, right? Now, we know that when the KMNO4 react in acidic medium H plus, then its oxidation changes from, this will convert into Mn plus 2, right? So here the oxidation state of Mn is what? We know that K having plus 1. So this is X and this is minus 2 into 4, 8. So X is comes out to be 8 minus 1, that is 7. The oxidation state of Mn is here is plus 7. And here the oxidation state of Mn is plus 2. So what is the change here, beta? That is 7 to 2. So oxidation number decreased by what factor? Oxidation number decreased by the factor of 5. So when the KMNO4 react with under acidic condition, change in the oxidation number is from 7 to plus 2, that is plus 5. Hence, equivalent weight of KMNO4 in the acidic medium is nothing but the molecular mass, which is equal to 158 for KMNO4 divided by 5, right? Divided by 5. So we can calculate. It comes out to be 31.6. So this is the equivalent weight of an KMNO4, right? So any substance that will undergo oxidation or reduction, we can calculate equivalent weight of that substance by dividing with the change in the oxidation number, that how much change are present in the oxidation state, right? Good. So I hope this is clear to you. Now, let's move to the next thing. For a volatile metal chloride, volatile means something we have a capability to form liquids, right? So for the volatile vapor, sorry, something which have a capability to form vapors are known as volatile. So for volatile metal chlorides, equivalent weight and atomic weight are related at like this. Atomic weight is equal to equivalent weight into valency. That is equivalent weight into valency. So this is how we can actually calculate for the volatile metal. Always remember some important note here. What are the important note here, beta? Just remember this thing. Atomic and molecular masses of element and compounds respectively are always constant, right? Atomic and molecular masses of elements and compounds respectively are always constant, but equivalent mass may be vary with the change of valency. So this one is very, very important point. Just remember this thing. Atomic and molecular mass of element is always remains constant, but equivalent mass may be vary with the change of valency. For example, in this case, here the oxidation state of Mn changed from +7 to +2. Now, in some cases, the oxidation state of Mn changed from +7 to +5. Now, the change is only 2. Now, it comes out to be 158 divided by 2. So, it comes out to be more. है ना? So equivalent mass is always change, always vary with the change in valency. So this one is very important and understand this thing better. Now the second point is the valency of element forming isomorphous. What is isomorphous compound better? Can anyone know what is isomorphous compound? Okay, let me tell you. The valency of the element forming isomorphous compound, that is the compound that have the similar constitution and the chemical formulae are same. It means what is isomorphous? Isomorphous means the compound that have a similar constituents and the chemical formula are also same. Example, valency of chromium, selenium, and sulfur in K2Cr2O4, K2SeO4, and K2SO4 are same. So they are called isomorphous. So valency of the element forming isomorphous compound, right, are the same. So this is also very important. For example, in this also chromium having how oxidation state 8-2, that is +6. As vanadium also having +6 and sulfur also having +6. So they also same oxidation state, right? So these 2 points are very important. Always remember what is isomorphous compound. This is clear to you? Right? Okay. Right. So this is all about how will you basically calculate the equivalent weight. Anyone, any kind of doubt, please ask me. I'll give you 1 minute for this. Just look at this and try to understand. If you are not able to understand this thing, then you can please ask me. I'll going to reply you as well. No doubt. Right. Okay. So let's move to the next concept, that is the percentage composition of compound. And this one is going to be also very, very important, that how will you calculate the mass percentage. So far, what we covered mole concept, we covered what is stoichiometric. Later, we are going to discuss the type of stoichiometry as well. And we already covered the thing like equivalent weight of an acid, base, or salt, or we can say the compound undergo oxidation and reduction. So we already covered this thing. Now, what is the mass percentage of a compound? So how will you calculate the percentage composition? So in a various compounds, if you have to calculate the percentage composition, right? If you have to calculate percentage composition, for example, someone says here in Na2CO3, just calculate the percentage composition of sodium, or we say carbon, or we say oxygen, then how will you calculate? So we can calculate by using such simple formula. So the mass percentage of an element is equal to mass of that element in the compound, right? Mass percentage of an element is equal to mass of that element in the compound divided by molar mass of the compound into 100, right? Into 100. So this is how we can calculate mass percentage of an element. I hope this is clear to you. How will you calculate this? Mass of that element in the compound into 100 divided by the molar mass of that compound. So let's see with example. This one is very important. This question is from basically JEE Mains, but when you solve such kind of question, this type of questions may come in your advanced paper as well, because this is very good question in terms of concept understanding. This question is very important. So try to understand this question, which type of question is this and what they actually ask in this question, right? So in this question, the ratio of the mass percentage of C and X are already given, right? So in this, the ratio of the C and X are already given, and the ratio of the mass percentage of CnH and CaNO of saturated cyclic organic compound X are 4:1 and 3:4. Then the mole of oxygen gas required for the complete combustion of 2 moles of organic compound X is. So we know that what is the molecular formula, beta? So what is the molecular formula here? So the molecular formula, because in this we have a carbon, hydrogen and oxygen, right? And they are called saturated cyclic organic compound. So for the molecular formula, we know that it is equal to Cn alkane. What is molecular formula for general molecular formula for alkane, beta? That is Cn H2n plus 2, right? And this is O2, right? So this is the general formula for this hydrocarbon. Now, if you want to calculate the percentage of carbon, then how will you calculate, beta? We know that percentage of carbon is equal to, what is percentage of carbon is equal to what, beta? Percentage of carbon is equal to 12 into n, because here the number of carbon is n. We represent a number of carbon as n. So 12 into n divided by the molecular mass into 100. On the similar basis, hydrogen percentage is what, beta? Percentage of hydrogen is nothing but, here hydrogen is 2n plus 2. So we know that this one is 2n plus 2 and number of hydrogen is always equal to 1 divided by molecular mass m. On the similar basis, what is the percentage of oxygen? So oxygen percentage is equal to what? That is 2. So that is 32 upon m into 100. Now, we know that to be saturated and alicyclic, condition is given, saturated and acyclic. So for saturated and acyclic, N is equal to 2 only. Because we know that saturated means what? Saturated means single bond, alkane. So for alkane, the general formula is Cn and H2n plus 2 only, right? So here N is equal to 2. So for saturated, we know that N is equal to 2. So just remember this. This data is already provided in the question. This is saturated and a cyclic compound. So N is comes out to be 2. Now you can calculate the percentage of carbon. So percentage of carbon here is 24 divided by molar mass into 100. Similar, what is the percentage of H, beta? Tell me fast. That comes out to be 2 plus 2 plus 2. 2 into 2, 4 plus 2, 6. So this is 6 into m into 100. This is 100, right? And the similar basis, percentage of O. So percentage of O is nothing but 32 m into 100, right? Now, in this question, it's already given that, what given that, beta? Carbon and hydrogen percentage having is equal to 4:1, right? This is already given now. Carbon to compound X are 4 and 1, right? So, and 3, 4 respectively. So, carbon and hydrogen having in ratio 4:1 and carbon and oxygen in the ratio 3:4. So, this is how we can calculate, beta. Tell me. Yes. So we can calculate this thing now. We know that what is this is 24 divided by 6, right? And this is equal to 4:1. Similar carbon and oxygen ratio. So carbon and oxygen ratio is what? Carbon percentage and its ratio with oxygen percentage. So it's equal to 3:4. That is 24 upon 32. It comes out to be 3:4. So X is what? So X is nothing. This is proof from this one that comes out to be 4:1 and 3:4. So what is X? So X is nothing but X is here. We can derive this formula. X is nothing but X is comes out to be C2H6 and O2. So this is the important thing. So this is how we can derive this. This is the basically the compound that we are going to burn this, or we can say this compound is undergo combination equation. How will it react, right? So this is how we can calculate C2H6 and O2. I hope this is clear to you. How will you calculate this C2H6 and O2? Initially, we considering this CnH2n plus 2 into O2. Later, we have to calculate percentage of carbon. We know that how will you calculate percentage carbon? That is 12 into number of carbon into M. So on solving, we'll get this. That is, this one is 24 upon this. This one is 100. This is 6 upon M into 32 upon M. So from this, we can calculate percentage of C and H. So C and H comes out to be 24:6. We have percentage of carbon, we have percentage of hydrogen. So C ratio H comes out to be 24:6. That is 4:1. And this 24 and 32 comes out to be 3:4, right? So by using this equation, equation 1, equation 2, and this is equation 3. So from this 1, 2, 3 equation, we get this 4:1 and 3:4. So by this, we came to know, yes, here N is only 2. So the formula of this compound X is C2H6 and O2. This is clear to you, right? Now, let's how will you write the oxidation reaction, combustion reaction? So we know that how will you write the combustion reaction better? We know that here the compound is C2H6 and this is nothing but O2. Now, how will you write the combustion reaction? We know the combustion reaction will write with O2, right? So how will you write beta with O2? That is just balance the equation. That is 5/2 O2, and this will gives us CO2 plus H2O, right? CO2 plus H2O. So how many moles of CO2 beta? So 2 mole of CO2 and 6/2 mole of H2O, or we say 3 mole of H2O, right? So this is all. Now, we know that 1 mole of this compound, 1 mole, react with 5/2 mole. Now we are using the mole concept, right? So 1 mole of this compound react with 5/2 mole of O2. So we can say that now, 1 mole of this compound required 5/2 mole of O2. So in this question, what they ask, the mole of oxygen gas required. Yes, the mole of oxygen gas required for the complete combustion, right? So how will you calculate, beta? How will you calculate? So if the 1 mole of this requires 5/2 mole of O2, or we can say 5/2 mole of O2 required 1 mole of C2H6 and O2. Then 2 mole of O2. How many? It is better. How many? 2 mole of this compound X is required. How much? 1 mole of this compound required this. So 2 mole of this required. 2 mole of C2H6 and O2 required 5/2 into 2. So 2 to 2 cancel. That is 5 mole of O2. 5 mole of O2. So this is the correct answer for this question. 2 mole of C2H6O2 required 5 mole of O2. So the correct option is 5 mole. 5 mole of O2. So this is the 5 mole of O2. I hope this is clear to you. How we'll calculate this? सबको क्लियर है क्या? सबको समझ आ गया? Okay. So now there are some useful formula related to the moles and concentrated terms. So let's see one by one. This one is very, very important formula. So try to learn this formula as well. If someone says how to calculate the number of millimoles, right? Number of millimoles is equal to molarity or into the volume in the milliliter. So this is how we can calculate number of millimoles. Similar moles we can calculate millimoles divided by 1000. Now, number of equivalent of a substance is equal to weight upon equivalent weight. So this is how we can calculate number of equivalent of a substance. Similar, if someone says how to calculate the number of milli equivalent, we can calculate 1000 into the weight upon the equivalent weight, or we can say this one is equal to normality. So normality into volume of the ml. So there is a relation between the normality and molarity, that normality is equal to n factor into molarity. So this is how we can calculate normality and molarity. What is this n factor? For example, in terms of H2SO4, H2SO4 having 2 molar. So we have a 2 molar solution of H2SO4. Then how will you calculate normality? So we can know that normality is nothing but N into molarity. So molarity here is 2. Right. What is N factor? So we know we already discussed this thing now in H2SO4. How many replaceable H plus are there, beta? 2. Because basicity of H2SO4 is 2. So we have a 2. So 2 into 2, it comes out to be 4. So normality comes out to be twice, or we say 4 times 4 normality as compared to molarity of the solution, right? So we can calculate n factor like in terms of acid, we calculate basicity. In terms of basic, we have to calculate acidity. In terms of salt, we have to calculate the positive charge of the metal. In terms of oxidation reduction, we have to calculate how much change in the oxidation state, whether it changes +2, +3, +5, and so on. So this is all about the n factor. So if you know the n factor, then we can calculate normality, which is equal to molarity into balance factor. Someone say n factor or balance factor, where Y is the acidity, basicity, number of replaceable H atom, change in oxidation state, and all. Okay, so this is the very important relationship between normality and molarity and how we'll calculate. Right. Now, the number of equivalent is equal to Y into number of moles, and number of milli equivalent is equal to Y into number of millimoles. So this is similar. Mole fraction of the solute, we already know N into N plus N. So we can calculate mole fraction of the solution. Similar for the very dilute solution, the mole fraction of the solution is become M into M, where M is the molecular weight and small m is the molality divided by 1000. Similar, when the volume is not given, then the density, when the density is given. So we can use this formula. Density of the solution is equal to molarity into 1 upon molality plus molecular weight of the solute in, divided by 1000. Similar way, percentage by weight, we already discussed this thing. Weight of the solute upon the weight of the solution multiplied by 100, and percentage by volume is equal to weight of the solute in gram into 100 divided by volume of the solution in milliliter. So 1 milliliter is equal to 1 normality KMnO4, which is equal to 1 ml of 1H2O2. So this is how we can calculate. This thing is also very, very important, this one. That is, molecular weight is always equal to twice into vapor density for the gaseous phase only. But remember this, molecular weight, or we say molecular mass, is equal to 2 times of the vapor density. Right? Now, so we already discussed, we have to, before solving any sociometric problem, this thing we already discussed now, before solving sociometric problems, we must identify which type of sociometric problem is this. So first of all, you have to identify the types of sociometric problem that are present in this question. So if you know the type of sociometric problem, then you can easily calculate this. Right. So let's see how will you calculate this thing. So depending upon on the unit, sociometric problem may be classified into the following relationship. And what is the relationship, beta? The first one is mass relationship, or we say gravimetric analysis. The second one is mass volume relationship. And the third one is volume relationship. So we are going to understand this thing as well. Try to solve one numerical from each way, so that we can able to understand the concept in a good way, right? Now, the first one is mole method, or we say based on the mole concept. So first of all, for this, how will you solve the question if the question is based on the mole method, or if you try to solve the question from this method only? So first of all, write the complete and balanced chemical reaction per the information given in the problem. So whenever the information given in the problem, whatever the information given in the problem, write the complete and the balanced chemical reaction. The second step is the stoichiometric coefficient in the balanced chemical reaction represents the relative number of moles of the different reaction components, relate the amount of the reaction component concerned with the help of the mole. Now calculate the unknown amount of the substance using the unitary method. Like 1 mole is required this much of this, so 2 mole required this much of this. So just by knowing unitary method, you can calculate. So this is a very simple question. And try to solve this question better. Try to solve this question because this one is very important and very simple question, which is basically based on the mole concept method. So what the question asks, so what the first step? First step, write the balanced equation, right? So calculate the weight of carbon dioxide formed by the complete combustion of 1.5 gram ethane. So you have to go give the complete combustion of 1.5 gram of ethane. So what is ethane beta? This is nothing but C2 and this is H6. So this is ethane and it will undergo complete what? It will undergo complete combustion. So it react with O2. It will equal to 7 by 2, right? 7 by 2 O2 to give 2 CO2 plus 3 H2. 2 CO2 plus 3 H2. We can also remember this like 2N plus 1 divided by 2, right? So here the carbon is nothing but 2 and H is 6. So we can use like this 2, N is what? 2 plus 1. So 2 to 4 plus 1 divided by 2. This is equal to 5 by 2, right? This is equal to 5 by 2, not 7 by 2, right? So this will require 5 by 2 only. So it's not 7 by 2. So just correct this. This is 5 by 2, right? Now, this one is oxygen, 2 to the 4 oxygen, 4 oxygen plus 3 O. It means 7 oxygen, 7 oxygen. So 7 by 2 O2. Right. Okay. So we can calculate this by using this formula as well. 2n plus 2n plus 2 here. Sorry for the mistake. 2n plus 2. So it will become 7 by 2. Right? 2n plus 2. Just remember this formula. So here we can observe that what is the balanced chemical equation here? C2H6 plus 7 by 2 O2. This will gives us 2 CO2 plus 3 H2. Now, what the question asks? Calculate the weight of carbon dioxide. So you have to calculate the weight of carbon dioxide in gram. So let's convert each one in a gram because always convert each either in mole or in gram or in atom. So always maintain the same things all over the reactant and product side as well. So in this we know that that is 12 into 2, 24 plus 6, that is 30 gram. So the 30 gram of ethane, right? So the 30 gram of ethane will give CO2, we know 44. So we can calculate like 2 into 44 gram. So we can say that 30 gram of ethane, that is C2H6, produce 88 gram of CO2, right? So 1 gram produce 88 divided by 30, and in question they ask 1.5 gram. So 1.5 gram multiply by 1.5 gram, right? So just calculate this. You can easily calculate. So it comes out to be 4.4 gram, right? So it will produce 4.4 grams. So the correct answer is option number D. So this is very simple question. Always use the formula first. First step. Always remember, write balanced chemical equation. If you write the balanced chemical equation, then in next term, just use the unitary method to solve out, right? So this is very, very simple one. I hope this is clear to you. This question I basically, why I am solving this question, because I want to clarify you. If you know the concept behind a small question as well, then you can able to solve some bigger question related to this as well, right? So try to understand the concept from this. How will you write the equation? How will you use the unitary method and all? So this is one of the method. How will you calculate the stoichiometric calculation? Anyone having any kind of doubt, or is it clear to you? Right? Okay. Now, the next one is equivalent method, right? So this is the equivalent method based on the equivalent weight concept. The first one is based on the mole concept, and this one is based on the equivalent weight concept. So how will you calculate for this? How will you calculate this? In a reaction, the number of gram equivalent of each reactant reacted result to same number of gram equivalent of each product, right? So in such reaction, the number of gram equivalent of each reactant is must equal to gram equivalent of each product. The previous question may also be solved by using the equivalent concept. How will you solve this? So we can solve this now. Like in a previous question, what is given? So in the previous question, we can observe now it is already given, that is C2H6. This is the reactant side. And what is the product side? 2CO2. So the equivalent gram equivalent of each reactant, right? So know that the number of gram equivalent of C2H6 is equal to number of gram equivalent of CO2. So what is the gram equivalent of C2H6? We know that C2H6 gram equivalent of C2H6 beta. What is the gram equivalent of C2H6? We know that the mass is given 1.5, and instead of molecular mass, we use molar mass divided by what? And divided by 14. What is this 14 beta? This is the equivalent weight of this, that is C2H6. How it will derive C2H6? Can anyone tell me? The factor, how the factor 14 and 7 comes? So this 14 and 7 are the change in the oxidation state of carbon from this to this. Let me show with an example. If I'm talking about C2H6 and this is CO2, right? So what is the change in the oxidation state, beta? So here the oxidation state of C2 is what? We know that this is 2x and this is plus 6 is equal to 0, right? So this is 2x is equal to minus 6, or x is equal to minus 6 upon 2, that is 3. So x comes out to be 3. So here the oxidation state is this. Now the factors 7 and 14 and 7 are the change in the oxidation state of carbon from C2H6 and CO2. So how oxidation state changes, beta? How oxidation state changes from this to this? Can you guess how the oxidation state changes? How the N factors comes into the picture? Right. Let me explain with the example. Now in C2H6, we know that carbon having oxidation state, right? Carbon having CH3, this one, CH3, this one again, right? So this is all about. So we know that oxidation state of carbon is nothing but 4. Oxidation state of carbon is nothing but 4, right? So the oxidation state of carbon is equal to 4. Now here in CO2, oxidation state of carbon is what? Calculate. You can calculate here also minus 2, and this is comes out to be minus 2 into 2, 4 plus 4. And here it is equal to what? Is it equal to minus 3? So minus 3 to 4. What is the change in oxidation state, beta? Minus 3 to 4. The total change is minus 3, minus 1, minus 3, minus 2, minus 1, 0. And again 1, 2, 3, right? So the total change is equal to 7. So this is how we can calculate the equivalent factors and factors for C2H6 and CO2. So this will comes out to be 14 and 7. So the just divided this molecular mass with 14 and 7, we get weight is equal to 4.4 gram. Is it clear to you? Yes. So we can solve this question by using equivalent concept as well. So it is totally based upon you. Either you have to solve this question by using this method or by using equivalent concept. Now, in second one, calculation involving percentage yield. So how will you calculate the any calculation which involve in percentage yield? So in generally when the reaction is carried out in the laboratory, we do not obtain actually the theoretical amount of the product, right? So in the actual practice, we always obtain the product less than what we expected from the theoretical product, right? The amount of the product that is actually obtained is called yield, actual yield, right? And the amount of product that is actually obtained is called actual yield. Knowing the actual yield and theoretical yield, the percentage yield can be calculated by using the formula. right? By knowing the actual yield and theoretical yield. So by knowing the actual yield and theoretical yield, the percentage yield can be calculated by using the formula. So what formula we use for calculating the percentage yield, beta? Percentage yield is nothing but it is equal to actual yield divided by theoretical yield, right? So we can calculate the calculate percentage yield by using a such simple formula like actual yield divided by theoretical yield into 100, right? So let's see the question and try to solve this question. I give you 2 minutes till I'm taking some water. Now, in 2 minutes, you have to solve this question, or at least you try to solve this question. After 2 minutes, I'm going to explain this, right? So what the question asks and how will you able to calculate the percentage rate? So just try to solve this question in a 2 minutes. After this, I'm going to explain you how to solve this question, right? So everyone, just try to solve this question. Okay, so how many of you solved this question? For the reaction of this CaO plus 2HCl, reaction is already given. CaCl2 plus 2H2O, H2O. 1.23 gram of CaO is reacted with the excess of hydrochloric acid, right? So 1.85 gram of Cl2 is formed. What is the percentage yield? So you have to calculate the percentage yield for this question, right? So what is the percentage yield for this question, beta? चलो मैं सॉल्व करता हूँ. Now, let's see. We know that here CaO react with 2HCl, right? So this CaO react with 2HCl to form CaCl2 plus H2. This is correct? CaCl2 plus H2. Clear? Okay. Now we know that CaO, 1 mole of CaO is equal to what? That is equal to 56 gram because calcium 40 and 16 oxygen. So this is equal to 56 gram of this. React with 2 mole of HCl to produce how much calcium chloride? This much. That is 1111 gram, right? So 56 gram of calcium oxide produce 111 gram of calcium chloride. So if the 56 gram of produce this much, then 1 gram produce 1 gram beta. 111 divided by 56. In this question, they want 1.23 gram. So 1.23 gram of calcium oxide will produce how much? That is 11156 multiplied by 1.23. So it comes out to be 2.43 gram. How it comes out to be 2.43 gram. But the theoretical yield is given. This is the actual yield, right? This is equal to actual yield. So actual yield 1.3 gram of Ca will produce CaCl2 111 divided by 56 into 1.23. So this is equal to 2.43 gram. So this is what the actual theoretical yield is given. 1.85 gram of CaCl2 is formed, right? So just use the formula. We already know this thing. The amount of the product that is actually obtained is called actual product, right? So what is the actual yield here? So the actual yield here is what? 2.43. Just solve this once, right? 111. Let me solve as well. So this is equal to 111 divided by 56, right? And this is multiplied by 1.23. It comes out to be 2.43, right? So this is the actual, right? This is the actual yield. So the actual yield is 2.43. So the actual yield is nothing but is equal to 2.43, right? So it is equal to 2.43. Now, what is the theoretical yield? Theoretical yield is given. Theoretical, theoretical. So theoretical yield is already given. It is equal to 1.85 gram. राइट सो दिस इज द थ्योरेटिकल इट मींस दिस क्वेश्चन मतलब ये गिवन था कि इतना बनना चाहिए बट हमने जब कैलकुलेट किया तो ये इतना बना 2.43 सो व्हाट इज द परसेंटेज यील्ड बेटा so what how will calculate percentage yield so we know the formula percentage yield actual yield upon theoretical yield so actual yield upon theoretical yield so we can calculate percentage like 1.85 divided by 2.43 into 100. So we get 76.1%. So this is the correct answer. So option A is absolutely correct, right? So this is how we'll calculate, right? So this is the formula for calculating the percentage. I hope this is clear to you. Now, this calculation is based upon involving percentage purity. So you have in calculation involving percentage purity. So in this type of calculation, depending upon the mass of the product, the equivalent amount of the reactant present can be determined with the help of a chemical equation. So knowing the actual amount of the reactant taken and the amount calculated with the help of chemical equation, the percentage purity can be determined. So how will you determine the percentage purity, beta? So percentage purity is nothing but is equal to weight of reaction required divided by weight of reactant taken. Let me tell you once, weight of reactant required divided by weight of reactant taken multiply by 100. So this is how will you know, this is how we can calculate the percentage purity. On the similar basis, calculation involving mass volume relationship. So how will you calculate when the calculation involving mass volume relationship beta? In such calculation, masses of the reactant are given and volume of the product is required and vice versa, right? So in such calculation, masses of the reactant are already given and volume of the product is required, or sometime volume of the product is given and masses of the reactant are required. So as 1 mole of the gas, we already know occupy 22.4 liter of volume at STP, standard temperature and pressure. Thus mass of the gas can be calculated by using this equation known as PV is equal to nRT. Or we say PV is equal to here, N is the number of mole which is equal to mass of the solid upon molecular mass into RT. So PV is equal to W upon M into RT. So this is how we can calculate. I hope this is clear to you. Right. Now, let's see this question for the gases or we say calculation based on the volume relationship. So basically, this is used for the gases, gas analysis, or we say adiometry. We are going to study this thing adiometry in detail in the next class as well. So these calculations are based on the various gas laws or initial topics of this chapter. Let us go through the some example, right? So let's see some example, and through this we can able to solve this question, right? So the first question is what the first question asks, beta. In this question, they ask about what volume of air, right? What volume of air, what volume of air having 21% of oxygen by volume is required to complete burn 1 kilogram of carbon containing 100% combustible substances, right? So how will you calculate beta what volume of air you actually required? So we know that the reaction is like carbon carbon and this carbon react with oxygen, right? This carbon react with oxygen to give CO2, right? So this carbon react with oxygen to give CO2. Now we all know that 12 gram 12 gram of carbon require how many? 12 gram of carbon required 1 mole of O2, or we say 32 gram of oxygen. Clear? 32 gram of oxygen for the complete combustion. Now on the similar basis, beta, 1000 gram of carbon required. So 12 gram of carbon required this much of oxygen. Now similar 1 gram of carbon required 32 divided by 12. So the 1000 gram is equal to nothing but 32 upon 12 into 1000. Right? So this is how we can calculate. So 1 upon 12, or we say this one. So in terms of mole, we can also calculate. If you want to calculate in terms of mole, then we can also calculate this, right? So this is equal to how much? So this is equal to nothing but just calculate this. So it comes around 32 and this. So it will comes around 32 multiplied by 1000 and divided by 12. So it comes out to be 266. It is equal to 2666.66 gram, right? This much of oxygen they require. We know that what is the molecular mass of oxygen, beta? So we know that the molecular mass of oxygen is nothing but 32. So just divided by 32. So what mole we get? So we get the number of mole of oxygen. Here we can write. So the number of mole of oxygen, they want number of mole of O2. So it is equal to 2666.66 divided by the molecular mass 32. This comes out to be 83.33, right? 83.33 mole. So this mole of oxygen, actually 1000 gram of carbon required. So till there is no doubt, when the carbon react with O2, so 12 carbon react 32 gram of oxygen. So 1 gram required this much, 1000 gram required this much. So we can convert this gram into mole. So they require basically 83.33 mole of O2. Now we know that for the complete combustion, volume of O2 at NTP is nothing but what? That is, we know that 1 mole is equal to how much? We know this thing. 1 mole is equal to how much, beta? So 1 mole at NTP or STP, 1 mole at STP is equal to 22.4 liter. So here 83.33 mole is equal to 83.33 multiplied by 22.4. So it comes out to be how much? It comes out to be 1866.592 liter. So this much of liter of O2 will be formed. Now we know that in the question is given 28% by volume. It means 21 liter of O2 is present in 100 liter of water. So this much of it present in how much? Can anyone tell me? Let's see the solution here, right? I'm writing the remaining parts here. So in the question I already given that 21 liter O2 present in 100 liter, because given na 21%. 21% means 21 liter of O2 is present in 100 liter. So 1866.592 liter of O2 is present in 100 divided by 21 into 1866.592. So it comes out to be 8.8885 into 10 ki power. How much? 10 raised to the power 3 liter, right? 10 raised to the power 3 liter. So this is the correct answer for this question, right? 8.885 into 10 raised to the power 3 liter. So I hope this is clear to you. How will you calculate? So which one is the correct answer, beta? Yes, B. So B is absolutely correct answer for this. That is 8.888, right? So this is how we can actually calculate. So in today class, what we already discussed so far, we already discussed about the mole, various types of mole concept, how to find the equivalent weight, what is equivalent weight is actually, and there are different type of stoichiometric problem. So we already discussed each and every type of stoichiometric problem, and also doing some numericals related to such different types of stoichiometric problems, so that we can able to understand. So we already covered this thing so far. Let's see some one PYQ questions that were coming in the previous examination in J advanced paper. So let's see one PYQ question and try to understand this question, right? How this question actually come and which topic from this question are, and now we are able to solve this question or not, right? So let's see one question. This question has basically coming in previous year. So what the question is, read this question very carefully, beta, so that you can write the answer for this question, right? So please read this question very carefully. What the question asks: in a chemical reaction between stoichiometric quantities of KMnO4 and Ki in weakly basic medium. So here the condition is given weakly basic medium. What is the number of moles of I2 release for the 4 moles of KMnO4 consumed? Right? So either you use mole concept for this question, or we use equivalent concept. So from above these two, you can use any of this, because you have to find the number of moles of I2 release for 4 moles of KMnO4 consumed. So how will you solve this question, beta? Let me first write, what is the first step for solving such questions? First step is write the balanced chemical equation. So the chemical reaction between KMnO4 and Ki. So this is KMnO4. So this is, let me write again. This is KMnO4, and this is react with Ki. So we know that in basic medium, right? In the weak basic medium, it will form MnO2 and I2. MnO2 and I2. Just balance the equation better. This is I2, so this will become, yes. So this is MnO2 and I2. Wait. Right? So this is KMnO4, and this react with Ki to give what beta? This will give MnO2 plus I2. Just remember this thing. Now, we can observe this thing here. What we observe here, beta? Because in this question, we have to, relation between I2 and KMnO4 only. So no need to write the entire equation. This is sufficient for the calculation. Now, for if you want to calculate, if you want to go through the equivalent concept, you must have to calculate the n factor. So how will you calculate the n factor? So here KMnO4, this is KMnO4, and this is I2. So what is the oxidation state here? If I'm talking about the KMnO4, so here the oxidation state of Mn is what? So we know that K is 1, Mn is X, and this is 8. So oxidation state X is equal to 7. So here the oxidation state of Mn is nothing but plus 7. And here the oxidation state is nothing but 4, because oxygen is minus 2 into 2, 4. So what is the change in the oxidation state? So change in oxidation state of Mn. So oxidation state of Mn is changes from plus 7 to plus 4, right? Plus 7 to plus 4. The total change is what? That is 3. The total change is 3. Now, similar, if I'm talking n factor, so this is the n factor for KMnO4, n factor for manganese, Mn. Similar, if I'm talking about Ki, right? Ki. So here, what is the n factor of Ki, beta? How will you calculate this? So the n factor of KMnO4 is clear. Now, similar for Ki, this is 2I negative. And from this 2I negative, it will convert into I2. So the total change in oxidation state is 2. So here n factor is 2. So n factor is 3 and n factor is 2. Now we can write, now we know by the law of equivalent concept, what we know that equivalent of reactant is equal to equivalent of the product. So we know that equivalent of KMnO4 is equal to equivalent of I2, right? So equivalent of KMnO4 is equal to equivalent of I2. So how will you calculate, beta? Tell me. So what is the equivalent of this? So we know that equivalent weight is nothing but n factor into the number of moles. So this is n factors into number of moles. This is also equal to n factors into number of moles of I2. So what is KMnO4? For the KMnO4, we know that n number of moles is equal to given, already given. That is the 3 mole, right? So, n factor is 3 and number of moles is already given, that is 4. 4 moles of KMnO4. Here n factor is 2 and number of moles you have to calculate, right? This one you have to calculate na number of moles. Good. Now this is 12. So this is 12 divided by 2. So this is comes out to be 6. So what is the number of moles of I2 beta? So number of moles of I2. This is nothing but equal to 6. Right? So this is the number of moles of I2. So this is how we can calculate the number of moles of I2 and it is equal to 6 mole. So this is very simple question. And this is your PYQ question generally came in your PY previous year advanced paper. So for this question, we use the equivalent concept, and by doing this concept, we are able to solve this question, right? So basically, in this question, you have to find the number of moles of I2 released when the 4 moles of KMnO4 is reacted. So by doing this, you can calculate the number of moles that you must required when the 4 moles of KMnO4 are consumed. So the correct answer for this question is 6. So such type of questions were generally asked in your previous year examination. So this is one of them, right? Now, on the similar basis, the second question is also the PYQ question. This question is also coming in your previous examination. What the question state better? The ammonia prepared by treating ammonium sulfate with calcium hydroxide is completely used by NiCl2.6H2O to form a stable coordination compound. Assume that both the reaction are 100% complete. If 1584 gram of ammonium sulfate and 952 gram of NiCl2.6H2 are used in the preparation, the combined weight in gram of gypsum and the nickel ammonium coordination compound, thus the product is. So this is a homework question for you all. Try to solve this question on its own level, right? And if you face any difficulties, any problem, then I'll explain this question in a next class, that is tomorrow, right? So let me give some idea, some hints so that you can able to solve this question. So basically in this question, what they ask, they want to want to calculate the total mass, right? The total mass of this. So you have to calculate the combined weight in grams of the gypsum and the nickel ammonium coordination. So they want to calculate the mass of gypsum and the nickel ammonium coordination compound. So what the product is. So let me write the reaction. It is very useful for you so that you can able to solve the question. So I'm just writing the equation here. So the ammonia prepared by treating ammonium sulfate. So first of all, write ammonium sulfate. The ammonium sulfate having formula NH4 twice SO4. So this is ammonium sulfate, and this ammonium sulfate react with calcium hydroxide. So this is CaOH2, right? So this ammonium sulfate react with calcium hydroxide is completely used by NaCl4 to form a stable coordination compound. Right. So when these two react with each other, what they'll form? They will form CaSO4 dot 2H2, also known as gypsum, plus this will form 2NH3. So this is known as gypsum. Gypsum. Now, in the next, they say when the NiCl dot 6H2O, that is NiCl2 dot 6H2O, this react with 6NH3, right? 2 gives us, what they gives us beta? 2 gives us Ni complex form, Ni NH3 6 Cl2, right? Cl2, and this is nothing but 6H2, right? This is nothing but 6H2O. So you have to calculate the total mass of this, right? So you have to calculate the total mass of this, that is gypsum, and this one is known as nickel ammonia coordination compound. Nickel ammonia coordination compound. Right? So you have to calculate the nickel ammonia, this mass gypsum 1 and 2. So you have to calculate the combined mass of this gypsum and nickel coordination compound. So I hope this is clear to you, and I hope you like the session. We are covering all the important term related to this chapter. Now in tomorrow class, we are also going to see this chapter as well and try to understand some important concept for the advanced level, like different type of titrations and all, and try to do more questions, more PYQ questions in tomorrow class. So till just revise this class and try to understand the topics, try to solve the question as much as you can, so that you are able to understand this thing, right? So let's meet in the next class. Till take care and just read it and just enjoy your study.